This is ImmunoAfrica, a podcast dedicated to spotlighting African immunology research.
Hello, I'm excited to have you join me on this edition of ImmunoAfrica's Graduate Student Series. This series offers emerging and aspiring immunologists the opportunity to connect with, learn from, and be inspired by some of the most talented immunology graduate students from Africa. This year, we peek into the fascinating work and busy lives of 4 immunologists in training, representing 3 African countries, Benin, Mozambique, and Nigeria. Vania, Segun, Onyeka, and Deo-Gracias joined me to talk about the challenges they are addressing in the field of immunology, which include training immune cells to fight cancers better, protecting fetuses from maternal parasitic infections, characterizing immune responses locally, and designing a multi-target vaccine. Away from their diverse interests and unique journeys, these talented scientists are driven by a singular purpose, an unwavering commitment to helping Africa realize its full potential in scientific research and development. The next guest on this series is Onyeka Chukwudozie. So, Onyeka Chukwudozie is a virologist, immunologist, and structural biologist from Nigeria. So he had his first degree from the University of Lagos, where he studied cell and molecular biology. He's currently a PhD candidate at the University of California, San Diego, and a member of the Erica Ollmann Saphire Lab at the Jolla Institute for Immunology. So Onyeka is a global health expert interested in Lassa virus research, and he has also been the recipient of prestigious fellowships, the Curci Fellowship, which he recently got, and also he was once a Merkin Fellow, during which he collaborated with the International AIDS Vaccine Initiative. So currently, Onyeka is leading research on the largest study on Lassa virus antibody discovery, which will study immune response of the Nigerian population to Lassa virus infection. So I think first thing I want to say is congrats on the fellowships you've been winning. I saw the earlier announcement that you made a few weeks ago. So big congrats on those prestigious wins that you've been getting in the course of your PhD program.
Yeah, thank you so much. I appreciate that. Yeah, thank you.
Yeah, so I think to delve into the conversation, the first question I'm just tempted to ask is why immunology? So what got you into the field of immunology?
So from my first degree, I did cell biology and genetics at the University of Lagos. So I did also more genetics. So immunology wasn't something I studied during my undergrad. I was never exposed to any form of immunology, even though I understand that antibodies have a Y shape, but I never knew much about antibodies itself.
Yeah.
So when I started, before I started my PhD, my interest in immunology peaked during the COVID period. When there was a shutdown, so I was in my house. So I was like, I can't just sit and do nothing. Yeah, so I started researching. At first, I started with bioinformatics. So I started exploring genomic data online and see what I can do, how I can design peptide vaccines. And I discovered that, oh yes, I can actually design a peptide vaccine using genomic data online. All I just need to do is to look at the antigenic regions of the proteins and see how I can use that to design an antigenic vaccines. And from there, I started studying immunology, and I also got this travel fellowship to Bahada, Ethiopia, before the outbreak. So I was in Ethiopia for 2 weeks where I studied immunology with some world-renowned immunology professors that were there. So I had the opportunity to also get exposed to these people. And I thought, oh, nice. I think immunology is a very cool field. And I started exploring immunology, started going online, see how I can combine bioinformatics and immunology. And I discovered that yes, and these were self-taught. I discovered that yes, both can work hand in hand. And after our first publication and the +1, I remember, I felt like, I think this would be a very interesting field. And still, I didn't really go into it. So when I got to the University of California, I just kept my mind open. So I just left an open mindset. Okay, let me do virology first, yeah, because that was the first lab I rotated in. And I rotated in my current lab and I discovered that I think I love immunology. Yeah, because there's so much stories behind immunology, so much, especially when it comes to infectious diseases. I feel like virology is good, it's just the surface, but immunology tells you how your body fights this infection. So I feel like I really, really, really love that. Yeah.
So I want to ask about your current research. What are the questions driving your current research, and what's the primary problem it tries to tackle?
Yeah, Lassa virus was first diagnosed in 1969 in the Lassa town in Borno State. And ever since its first diagnosis, it's been spreading across West Africa. And currently there are 8 lineages of Lassa virus. So when I mean lineages, it's like a group of family members. They're the same virus, but they have a slightly different mutation across them.
Okay.
So which makes it very difficult to design a vaccine that targets all these lineages, right? So even if you design a vaccine for one particular lineage, there's a possibility that that vaccine might not work across other lineages. Now, the geographical distribution of this virus is in Nigeria, which happens to be the epicenter of Lassa virus. We have about 4 lineages: lineage 1, lineage 1, 2, 3, and 6. Then the most studied Lassa virus lineages is lineage 4, circulate in Guinea, Liberia, and Sierra Leone. So even while I was at Imperial College, while I collaborated with them to test the immunogenicity of the recombinant vaccine they were testing, it was on lineage 4. So, and we have lineage 5 in Cote d'Ivoire, Mali, and we have lineage 7 in Benin and Togo, and lineage 8 in Benin. So the idea is every work on Lassa virus is how can we discover an antibody that could cross-react with all of these lineages, and not just cross-react, but has the potency to actually neutralize all of these lineages. So they've done some studies on lineage 4, which is like the prototypic one which we study. And in Sierra Leone, we have a population of just 8 million people compared to Nigeria with a population of 200 million people. Mm-hmm. And from the study of lineage 4, yeah, they discovered about 5 or 6 antibodies that could actually cross-react to all of the lineages because of the conservancy of the epitope where they bind. So the epitope is sort of like conserved across all of the lineages. But Nigeria is special because we have 6 lineages circulating in Nigeria. And there's a high tendency that the vaccine you make for lineage 4 might not cross-react with the Nigerian population. It might not work for the Nigerian population. So the idea is Nigeria is like the most populous country in Africa. So we can't just leave it that way. Nigeria would definitely give us something interesting, especially on how we can better design the vaccines. Because the moment you study each of these lineages, you start seeing the difference in terms of the protein composition, the amino acid composition. And for you to design a pan-Lassa vaccine, you need to take into consideration the differences between these lineages for you to effectively design a very good vaccine architecture. So the idea was there are currently no B-cell studies when I mean B-cell studies, antibody responses for lineage 1, 2, 3, and 6, which is like 4 out of the existing 8 lineages. So the idea was like, we need to study these lineages from Nigeria and see if the Nigerian population are eliciting antibodies that could potentially cross-react with all lineages of Lassa virus that do exist. So we're hoping to see public germlines. We're hoping to see public germlines. And when I mean public germlines, that potentially elicit antibody that we can use as immunotherapeutics. against all other Lassa virus lineages. Yeah, so we're trying to see how we can better design a vaccine by studying how the B cell respond to the antigens, and two, we're trying to see if we can have what we call, I usually refer to it as antibody cocktails, composition of different antibodies that could be used as immunotherapeutics. Yeah.
Great. So what are like some of the problems that you think this research would solve in the context of Nigeria, because it's largely focused on Nigerian population, and then also in the context of other West African countries that are affected by the disease? And then do you think like maybe your studies could provide a template for, understanding other viruses that still have the potential to wreak so much havoc in the continent? Of course, we are talking now about mpox that has just been, same thing that happened 2 years ago. We are having it repeated, declaring it as a public health emergency of international concern. So what role do you think your study will play in tackling some of these current issues and even potential future issues?
Yeah, I mean, it's a big one. First, it's number one, is the largest study on the Lassa virus antibody, isolation, purification, and studies for a human study. It's the largest by far because we're working with about hundreds of people. Mm-hmm. And I was in Nigeria last year, and I was isolating antibodies from people who survived Lassa virus infection, and it was not a child's play. I could say that it was a lot of work for me, because I collaborated with the Center for Human and Zoonotic Virology at the medical campus of the University of Lagos, where I live. And I work with Professor Milavo, someone who I really respect and revere. So it's a large study on Lassa human antibody isolation. And of course, it's going to serve as a template, being the first study to study the B-cell responses of the Nigerian population to Lassa virus infection. And not just one lineage, you're talking about 6 lineages here. It will also serve as a template because we are deeply hoping, which I believe, to discover antibodies that would cross-react, which I can say for now, I'm beginning to see them already from the little experiment I already started. I'm beginning to see them already, which could cross-react with older lineages, across West Africa. And antibodies we discovered could be used as immunotherapeutics for the treatment of Lassa virus infection or fever. So the major thing we're hoping to get, like I said, is for the design of vaccines, because when we design vaccines, we use the architecture of the virus itself. And most vaccines has been on lineage 4. They've studied, they've given the structure, the protein structure of lineage 4. So people who are designing the vaccine knows what they are designing. But there are 1 or 2, 3, 4, 5 changes when it comes to older lineages, like 1, 2, 3, and 6 that circulate in Nigeria. So it's best we study these lineages individually to see what are the differences that make them make them not to be prone to vaccines designed for lineage 4. So once we understand these differences, we can then take them into account and design better vaccines that incorporate all of these differences across all lineages. For example, lineage 1 has a particular mutation, very long alginine, and alginine is a long bulky amino acid. Because of that one mutation, lineage 1 is actually evading antibody response to a particular site in the virus. So we need to study all of these lineages before we can have a good pan-Lassa vaccine.
So you are a structural biologist, you are also a virologist. So I think from when you were speaking, it's obvious that these skills or the expertise you have in these different fields come to play in your work as an immunologist. So I just wanted to just highlight how, having these skills across multiple fields has contributed to the progression in your career and then your ability to tackle some of these tough questions. And you highlighted earlier on, of course, that you were self-taught, and when you were delving into the field of immunology and bioinformatics, that you had to do a lot of learning by yourself. So just let us know how all of these learnings and expertise you've gathered from various fields contribute to your current work.
Yeah, I mean, to effectively design a vaccine, the field of structural biology is pivotal because it's one thing to say this antibody, or when you administer the vaccine to people and you're testing the immunogenicity of the vaccines or the antibodies, one thing to say, oh, this antibody neutralizes virus, right? We know from neutralization, pseudo-neutralization assays, you could tell. But it's a question of how did they neutralize? That's what structural biology would tell you. Now, this antibody knocks off this virus and kills it completely, right? And prevents the virus from different functions we don't know of. Now, it could be like, okay, yeah, this antibody neutralizes virus. It's a question of how. Is it by blocking the virus from interacting with the receptor? Is it by preventing the virus from interacting with the lysosomal receptor, especially when they are endocytosized into the cell? What are they doing? Is it by locking the virus in its prefusion conformation so they don't transition to postfusion where they interact with membrane fusion and then release the genetic materials into the cell? Now, this is what structural biology will tell you. Now, structural biology brings you into that realm of now seeing how the interaction is being done. Where are they binding to the antigen? This antibody is potent. Where does it bind? By binding, what are the amino acid interaction there? What are the electrostatic interaction within that region? Having this information makes vaccine design and production easy. So that we want to design vaccine that could actually give us that same type of antibody response. So we are not designing vaccine blindfoldly by saying, oh, let's just try this, let's do something random, right? Structural biology brings you into that light of, oh, this is what is happening at the atomic level. Yeah. And structural biology is a very tough field. And when I mean tough, it is very tough. It's not something, it combines math, a lot of coding, and even biochemistry, because you need to provide the protein for you to have the high resolution structure. And when you're talking about high resolution, you're talking about like from 1 angstrom to 3 angstrom. So it takes there's a current structure I saw. It's not published yet. So I solved the Ebola structure in complex with the P6 antibody from Africa. So it took me like more than 1 year to solve that. So you see how the antibody is piercing through the virus. It's using the CDR. So these things are so rich that it could help us design a better vaccine. So we're not doing a random thing. And also for virology is a very interesting field, like I said. It's a very, very good one. I do a lot of, for example, I do pseudo-neutralization assays where I have to produce a pseudotype. So for example, Lassa virus is a BSL-4 agent. So it's not something you do in a BSL-2 lab. But in order to, an alternative is to say, how can we do like a pseudovirus where we use a VSV backbone, then we make the VSV express Lassa virus surface protein. So which could still give us like a real sense Lassa virus itself. Then we test for neutralization assays. We also test for the viral titer. Then for immunology, we do a lot of antibody discovery. We have to sort plasma B cells. We have to do all of this discovery. So we combine this thing together. Also protein engineering. There are times we have to engineer proteins, we have to purify proteins. So I think for our lab, we're doing what is called LSA Catera, which is a high throughput antibody discovery. So you just put in everything there, and within 4 hours or 24 hours, you get all your results. Why there's another one called optofluidic beacon. So it's like a very high sophisticated machinery, which we use in discovering monoclonal antibodies. So I feel like with this advent of technology, it's making life much more easier now. Now we are now precise with what we are designing. We are not doing something random.
So we've discussed a lot of your research work, and I think it's high time that we'll just get to know you as a person and explore some of the your experiences or challenges as a graduate student, and then some of the challenges you've had so far in your journey. So I think something I would just want to ask first of all is, so how do you get to manage yourself and manage time as a student and still make time for other activities if you do other activities aside research?
Yeah, I'm gonna be very, very sincere. I mean, PhD potentially will take away your social life. Yeah. So I, for one, I used to be like, um, I do curricular activities. Like I used to be a singer, so something like that. But I have to take a break sometimes. So sometimes, even while talking to you, there are times I've gone for therapy just to find a way to balance work and life as a person. So it's not something I say, oh, it's easy. No, it's not. It's not easy, especially when you're doing something huge. I mean, I travel a lot for my research. I do a lot of international collaborations, and I don't think I've had that time to like for more than 2 months. Like, oh, I'm in my house and let me chill for 2 months. It's always like back to back, back to back. And we have to, because of the impact of this thing, we have to do it. We have no choice than to do it. But my advice for people who find themselves in these shoes, it's not to lose yourself. Research is one part. You need to understand that research is just a part of you and not you. Because there are times the research will fail. I've had failed experiments, tons and tons and tons of failed experiments.
Yeah.
But it's something I always tell myself, this is not you. This is just a part of you that is not working. So you need to go get strength from the areas that are working to continue this part that's not working.
Yeah.
So that I find my best to find a balance. Even though I'm gonna confess, I go to the lab sometimes during weekends. It's not a good practice that much, but I have to do sometimes, especially if it's based on the gravity of the experiment I'm doing. But to find a good balance, every weekend I go downtown, I drive down with friends, I have lunch, just to relax a little bit. On Sunday, I go to church and I relax. And the Monday, I'm ready for the new week. So I think it depends on the individuals here. But my ultimate advice is do not lose yourself. Research is not a totality of you. It is just a part of you. Yeah.
I think that's a great advice. So we should be committed, give our best, but we shouldn't lose ourselves in our in our efforts to find these answers and get all of these solutions to help the world become a better place. So I would want to ask. It's interesting you mentioned that you've been to Nigeria because of your research work, and because I want to ask. Oftentimes, when you speak with individuals already studying outside, outside the continent, outside the country, there are those who speak who still speak highly of the continent. Maybe they still have hope in the way educational research is, and there are those who who keep whining about, oh, things are not working yet, things are not working yet. But it's quite interesting that you came here to do some part of your work. So how do you think African students, graduate students, can support their colleagues or the younger scientists, the younger breed of scientists that are within the continent or still within specific countries?
Yeah. I mean, I love home. I say it every day and every time. I don't care what's going on. I don't care if there's I understand there's economic hardship and sometimes there could be tribalism or whatever. I love home. I love everybody. When I come home, I love it home more. I mean, I'm confessing to you, I love home. And because even when they say, oh, you'll be the best person to take up this project, I'm like, I'm very happy to. very happy to, because I'm a kind of a person who likes just sit back and start giving complaints. It's a waste of energy. Complaints to me is a waste of energy, and because I understand the country is bad, but what are we doing to make it better? It's a question. What are we doing to make it better? I was so proud when I was in Nigeria last year, and I was giving training to young people. I was letting them know there's hope. Initially when I met them, they were like, "Oh, they hate the country is bad." But over time, they started saying, "Oh, I was proud when they start telling me, oh, I also like to do something like this and also help my country." It doesn't mean you might come and live there forever, but there should be an impact. No matter where you go, there should be an impact to your country where you come from. And I think that's a mistake many people do when they get into grad school. And I've heard many people say it many times, "Oh, I'm done with that country. I'm no longer going back." It's no, and it baffles me sometimes. And I understand where all of this are coming from. They've been frustrated, but sometimes I just let them know that we're here to get best of this opportunity, get exposed to technology, understand science, so that we can one way or the other impact our nation back home, so we can have a place where we call home. So I still find time, though not too much of it. I still have people I mentor, like 2 or 3 people. So I'm a kind of a person. I mentor few people. Yeah, because I believe in the effectiveness of mentorship. I'm not the kind of person who want to have thousands at my back and I cannot find a way to connect with them.
Mm-hmm.
So whenever I mentor people, I connect with people. I have to talk to you either as a big brother, either as somebody who is experienced. I have to encourage you even when you have downtimes. That's why I pick few mentor people. I could just say I mentor like 3 or 5, 4 people. I make sure they succeed because I make sure I follow them. That's mentorship to me.
Yeah.
I make sure I follow their updates. I make sure I follow what's going on. I make sure that I follow what's stopping, where are you failing, what can we fix, all right? So I'm not a person who have a lot of people at my back, and I'm like, "Oh, dude, it's at the end of the day, I can't talk to you again in 2, 3 months. I have not heard from you." And you come back, "Hey, what's up?" So to me, that's not mentorship. To me, it's just followership. so yeah. So I just want to say it depends on the individual, but grad students in America are very, very busy. Yeah, yeah. I take that from me. I'm very, I could be frank. If they tell you they're busy, just understand that they are busy. But sometimes some individuals can still maybe make out a little bit of time to still, mentor. But I do mentor people, and I don't do it via social media sometimes. I could do it in person. Maybe I travel to a location and I see that this person is serious and I see that this person really want to do science. I love it. I like seeing people like that. And I'll just, okay, I'm going to mentor you. And that's how it goes for me. Yeah.
So what skills have what are the skills that you're proficient in and that you think someone who is in graduate school or someone who is preparing for graduate school should start preparing their mind to learn or to explore once they get into graduate school, especially in the context of your field? So what are those top skills that you think are important? Technical skills, and then you can also highlight other maybe soft skills or transferable skills that that has benefited you.
I'd say writing. Writing in grad school is indispensable. Writing is a big, big, big thing in grad school. It's when I mean big, you must learn how to write in perfection. And all this ChatGPT, you don't do that here. You don't use ChatGPT to write. You write as a very, very good grad student. You must know how to communicate science well in writing because you're going to apply for fellowships. You need to convince people to give you money, and you can only convince them with writing. You must understand. And when it comes to writing, you're not writing scientific jargons. You must learn how to communicate science in a simple term. Because the people who are giving you money, they are not scientists. Some of them are scientists, but some of them are just normal philanthropists.
Yeah.
So you must convince them that I need this money. So you must learn how to communicate science in a very plain language, which is the aim of science. You're not talking to professors. You're trying to, like, I'm doing work on Lassa now. I can't be giving jargons to a Nigerian. I can't come over and be giving jargons. I have to, even when I want to get samples from people, I have to give them this in the simplest of ways. Why am I doing this? Why do I need your blood sample? Why do I need your sample? I need to learn how to communicate in a very simple way. Because we think science is all about jargon. It's not jargon. It's just have to be very simple. Another thing I've learned is be patient. I'm not even talking about scientific skills now. These are personal skills that will help you as a scientist. You need to be patient because many times inferiority complex will hit you. You will feel like you don't belong. You feel like you don't deserve to be in the program because you didn't grow up being exposed to these things. You know, we in Nigeria, most research are not really up to par. So, but you get exposed to big machineries. I remember when I first working on electron microscope. When I saw it, I almost ran out. It was so huge. I saw a lot of wires connected here and there, and like, what's this? So I remember like I can, but over time, I begin to learn till I started knowing how to use electron microscope. So you want to be patient. You want to be calm, patient. Also, there's this one I really want to talk about, which is very, very important, which is very key. It's you just want to learn how to listen. Yeah, listening is a big deal. You want to learn how to listen to ideas because no matter how much you think your assay is perfect or your protocol is perfect, somebody has something which might be much more better than what you propose. You want to be humble to listen, but while listening to people, don't overdo it because your idea is your idea. Try to explore what's on your mind. But while you're listening to people, just see it as a way to refine what you already have in your mind. So I think those skills has really, really, really helped me. Yeah. Yeah. And also try to have social support. It's a big thing. I mean, I'm not married. So, but I try as much as possible to have social support from my partner. I try to have social support from my friends. We go out on weekends, we chill out on weekends or something like that. So I think these I know I'm not talking about science now. These are the personal skill you need to have to succeed in grad school.
I think those are I love the options that you shared. We talked about writing, patience, and then the ability to listen and to also be selective with the ideas that you got from other persons, and then also ensuring that you have access to support, social support to just encourage you, especially during downtimes, and of course maybe people that you can also celebrate with. Before we'll soon get to maybe wrap up the interview soon, but I also want to ask about what's that one mistake that you've made in your journey? Maybe you got an experiment or one mistake that still haunts you in your work.
I can't think of one right now.
Okay.
Because usually when I'm making mistakes, I just repeat it immediately. Yeah. So yeah, I can't think of one right now that I think of. None.
Okay,
Yeah.
that's fine. That's fine. Okay, so I think then let's hear from you regarding some of the values and principles that have shaped your life and your career so far. I think the first time I encountered you was I read your story. Maybe that was when you got into graduate school. I think there was this story you wrote, and then some blogs published it about your journey, and so maybe someone that comes from your background, even someone that doesn't come from a kind of background, but there has to be something about Onyeka that has, pulled you from where you started and brought you to this position or pedestal that you find yourself. So what are some of those things that, have, guided you or shaped you into the kind of scientist or human that you are today?
Yeah, I mean, this might sound cliche, but I think it's number one is the God factor. I mean, I was raised in the household of faith. I I believe in God so much, and I always acknowledge Him as my wisdom. So it's the God factor one for me. Two, ability to be kind to people.
Mm.
You just be kind to people naturally, and don't let people influence your personality. I know many people are broken in this world we are today now. So everybody have justification to be a bad person.
Yeah.
But don't let that change you as a person. You know, once you're being good to people and people don't reciprocate, it's their problem, not your problem. So don't let that influence you as a person. So that's what I've come to learn. And learning to forgive. Because even graduate school, people will still hurt you. I'm being frank. People will hurt you in graduate school. People will hurt your feelings. People will hurt your emotions. You must learn and learn how to forgive. You just have to learn how to forgive. If not, you will have so many baggages in your head. It will just distract you, from doing well. So you must learn how to forgive. It's something I really learned from my past. Just learn to forgive. And learn to get out of a toxic space. I feel like people need to learn that.
Mm.
They need to learn once something is beginning to rub you off of your person, your dignity, your personality, your peace of mind.
Mm.
Learn to get out of it because we tend to, and I'm not even talking about relationship, I'm talking about dreams. One thing we've learned as individuals is they've taught us how to pursue our dreams, but nobody has taught us how to let it go if it's no longer serving us. So there are times where you want to do something in life, and be it relationship, be it career, you want to do this thing, but you've noticed this thing is just taking your peace away. It's affecting your mental health. It's making you look lesser than who you are as a person, your values. Learn to step back and just sometimes you just have to walk away from it. Yeah. So another thing I've also learned is we need to learn how to segregate career from who we are. Sometimes people see it as a totality. So when you fail in one part of life, doesn't mean you fail completely. It's just one part that you failed in, right? So sometimes you need to go back, take a deep breath. Like there's this thing I do, mindfulness. I go to this place that makes me happy. Whenever I think of it, I'm happy. I take that energy, I go back to that side that's making me feel bad to see how I can now relax and fix it.
Mm.
So these are what makes me as a person. And the last thing is I'm not a person who complaining is okay. I mean, people complain, so it's okay. But I'm not a kind of person who likes sitting down and keep complaining. It's a waste of energy. It doesn't change anything. Complaint doesn't change anything. It's a waste of emotions. So rather than complain, I'm the kind of person who I leave, just get outside of my emotions and fix the fact. How can I fix this? And it's really working in my relationships too. How can we get this fixed up? Either just being fighting over something or something like that. So I think this is just the composition of me as a person. And one last thing, I'm a cheerful giver. Yeah, so I believe in because I also run charities for orphanages and for widows. I might not be as buoyant as the biggest people in the world, but I believe in giving. I believe in blessing people. Yeah, no matter the little you have, you can actually put a smile on people's face, and that really, really makes me happy as an individual. Yeah, so that's a sum total of who I am as a person.
Really inspiring values, really inspiring values. Generosity, mindfulness, and avoiding complaints, thinking more, being solutions driven. You're thinking about how to solve this problem instead of just complaining about it, and several others that you mentioned. So can you just give us maybe a snippet of what are some of your future plans? Say after your your PhD program, what will be next for you?
So on a normal day, I would just say, "Oh, I want to do a postdoc because the major goal for me is to be a professor." But I think now, the way life is hitting me lately, I'm like, I mean the way life is hitting me, the things I expect don't come the way I expect it to. And experiences will serve you in a way you do not expect it to serve you. And the future goal, I want to be a professor. I want to do a postdoc. But every day, it's like I'm always learning new stuff. My mind are always changing. My ideas are always changing. The world is evolving. So sometimes I just like, you know what? I just leave it in the hands of God. God, if you know where it's right for me to be after this PhD, just fix me there. So I'm no longer that guy who used to be confident. I'm no longer that person who used to be confident. And people are like, oh, that's weird. You're doing research. I was like, I know it's weird, but I'm no longer that guy who will tell you this is what I want to do. This is where I'm going. And I know where I'm going. I'm on the right path. Don't get me wrong. I know what I'm doing. But can I say, oh, this is it for me? No, because every day I just keep learning. Experience, I just like, for example, I thought this year I was gonna have a lot of publishable data. What's going on, you know? And it's taking me time to fix it. And I used to find solutions, but sometimes it just goes the way I don't expect. Even the simple of the experiment don't go the way I wanted to. So every day I just keep learning. I just keep learning. Experiences are just coming and it's shaping who I am as a person. But if you ask me, I say, oh yeah, I want to do a postdoc, and see if I can be a professor. But I think now I feel like I just leave it to God. Like wherever He wants me to be, I think I'll be there.
Yeah. I think, of course, I think you'll be safe for sure. You'll be safe in God's hands, and you'll be fine. But your journey has really been inspiring, and I want to say thank you so much for all you've been doing and the effort you've been putting into support and support people. So we have a few fun questions for you that we will use to wrap up the episode. So after the fun questions, we'll just take your final words or any other thing that you'd like to share. So I have two fun questions for you. So I'm not going to give you the privilege or the option to pick. So I'm just going to give you two random tasks. And so the first one will be, so this is the description of the task. So you're going to, turn a word into like an immunological term. So I'm going to give you like a random word, and then each letter of the word, you're going to, convert each letter to a terminology in your field or a terminology in immunology. So since you are into immunology, virology, structural biology, you could explore all of them. So the word I thought about is your name, Onyeka. So can we do that for your name? So you give us O for Onye and Ka. Convert each letter to a terminology that is in your field.
I'll say for O, let me start with N. I'll say N-link glycosylation.
Okay.
Yeah, I know if that works. Or I can also say neutralization.
It's fine. I think
is an assay.
Yeah, it doesn't have to be a word. It can also be a term.
Yeah. Yeah. Then for Y, I would say I'll say yellow fever, which is like sort of like a type of virus. Yeah,
that's fine.
Yellow fever virus. Then for E, I would say It's a lot now. For E, I'll say thinking from structural biology, E. Okay, for A, I'll say antibodies. For K, I'll say kappa. So kappa is a type of light chain antibody.
Yeah.
For E, I would say I don't know why E is just giving me difficulty now. E is a common word. I'd say I'll say Ebola virus.
Okay.
Then for O, I'll say O link glycosylation.
Okay. Yeah. I think let me give you a round of applause. So O linked glycosylation, L linked glycosylation. For Y you said yellow fever, E Ebola, then K kappa, light chain antibody, and then for A you have antibody. So yeah, that's great. Wonderful. So the second task, I have for you is yeah, I know graduate students read a lot of journal papers, and they talk so much about the number of journal articles they have to read, even though sometimes they don't get to read everything. But so on average, my first question is in two levels. So on average, how many journal papers do you think you read in a day or a week? And how many do you think you've read so far since you started grad school? Just a random estimate.
I don't finish one journal in a day. I'm not somebody who believes in reading because I believe in understanding concepts, and it's not something you rush in a day. So I could read one journal just 1 or 2, 3 days. Yeah, because I read the context, but you discover that most of the information are found in the supplementary data. And that is where you see a lot because they don't publish it because every journal has a limit of words and figures you can put. So they put most into supplementary. So I can read one journal in 3 days. So I can understand what they're doing. And it really helps me. I discovered there are new methods. So I need to take my time to read. So I don't believe in it. It's not a novel. It's a concept. So so in a week I could read just 2.
Okay,
yeah,
2 in a week.
I can just read 2 journals. Yeah,
Okay.
2 in a week. Yeah. Except if it's a review paper, I can finish a review paper in 1 day. But if it's a real science paper, something they did for 5 years, you want to do it in 1 day, no, I take my time. Yeah. So, and since I've been in grad school, how many papers in total? It's close to 100. Yeah.
That's a great estimate. Yeah.
Close to 100.
Makes a lot of sense. Yeah.
Yeah.
Yeah. So thank you. So I think it's important that you mentioned that you take your time to read and then supplementary data is something you also check, because sometimes when I see supplementary data, I'm like, let me just focus on the main paper and just forget about the supplementary data. I think that's something I would be deliberate about, and I believe other listeners should be deliberate about, looking up some of those data and seeing what they can glean from it. Yeah. So thank you so much, Onyeka, for a great chat. It's been really wonderful having this chat with you to get your perspectives and explore your journey so far in the field of immunology as an African graduate student, and to see how we can inspire the next generation of African immunologists and also share perspectives that can benefit both young, early career, and in fact, other senior scientists. So I would like you to just share your final words or closing remark on the episode. So what's one thing you would want listeners to take home from this episode or from this interview?
Yeah, me too. Every scientist out there, especially if you're from the beautiful continent of Africa, I just want to let you know that it will be rough. It's gonna be rough, and you might face 1 or 2 stereotypes. But the fact that you are in that program, you belong there. they see a potential in you, and that's why you're there. You're not there to fulfill any form of diversity quota. And that's the mentality I want people to get themselves out from. You're not there to fulfill any form of diversity quota. You are there because they see a potential in you being a good scientist. So I just want to say, don't try to be who you are not because you want to impress some set of people. Improve yourself every day, read every day, study, learn from people, but don't try to box yourself out because you want to prove to other people that you're good. You're going to lose yourself along the way. Be you. Those who really appreciate you, we appreciate you for who you are as a person. But all I'm trying to say is just always have in your mind, I am here because I deserve to be here. And for those who are applying to apply, be patient. You'll get it. Don't give up. It's very competitive. Try to improve yourself every day. Don't rush any process. I've seen people say, oh, let me go and publish 1 or 2 papers. If it's rubbish paper, so I can get into grad program. That's not a good scientific practice. Take your time, relax, get all the experience you need to get. Get all the experience you need to get. Be patient and learn. And you will definitely get into the program.
Thank you for listening to this episode on ImmunoAfrica. If you enjoyed it, please feel free to share it with your network. You will learn first about future episodes and get other immunology-related updates by following ImmunoAfrica _ the Immunology in Africa podcast on social media. See you on the next episode. Bye.